So far we've been looking at right triangles, and a triangle like right here, where we have a right angle in it, and then we have two other angles, one here and another one here. And we know that these two pieces here are what we call the legs, and this is my hypotenuse. We have done already the Pythagorean theorem, and we've looked at different ways we can use those, and even some special right triangles. With our special right triangles, we have looked at the 45, 45, 90 right triangle and a 30, 60, 90 right triangle. Today we're going to take us another step further, and we're going to start looking at what's called trigonometry. So what is trigonometry? Well, looking right here, trigonometry is the study of triangle measurement. Okay, we're looking at not just the sides, but also going to be dealing with the angles other than our 90-degree angle. We have the angle theta. Theta is what we refer to as our reference angle, so it would be marked at something like this here. Theta is our reference angle, the one that we're basing everything off of. Now the reference angle can never be a right angle. It's always going to be one of the acute angles that we have in our right triangle. And then we have some other terms that go with this, and we have ones called opposite. Opposite is the one that is not adjacent to our reference angle, our theta. So this would be my opposite side. The opposite side is the one that is not touching the reference angle. Okay, it's across from it, across from theta. Our adjacent angle, the adjacent side, is the one that is actually touching our theta. So this would be my adjacent side. The adjacent side is the one connected to or next to theta, and it is not the hypotenuse. It has to be one of the legs. Now our hypotenuse, the hypotenuse is always across from our 90-degree angle. So it's across from the 90-degree or our right angle. And we're going to be referencing these terms here. This is my hypotenuse. To use these to set up what we call trig ratios. So for trigonometric ratios, we have the terms sine, cosine, and tangent. For sine, we abbreviate it SIN, cosine is COS, and tangent is TAN. For the sine, the ratio of the leg opposite to the angle, opposite the angle, to the hypotenuse. The ratio for my cosine, so the ratio of the leg adjacent to my reference angle to the hypotenuse again. Notice both sine and cosine are related to our hypotenuse. Now for tangent, tangent is going to take and use just the legs, and it is my opposite leg to my adjacent leg. So look at how these things go together here. So this one right here, say my reference angle is right here, my theta. This would be my opposite, using OPP as the abbreviation. This would be my adjacent, ADJ for adjacent. And this one up top here would be my hypotenuse. I'm going to use HYP. So I'm going to help me remember these things. I'm going to refer to these as Sohcahtoa, because sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. Sohcahtoa, just as it says here. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. So looking at these right here, in our example, it says label the opposite, adjacent, and hypotenuse of the triangle using the reference angle A. So this is where my theta will be, right here. Reference angle A. So this is A, so down here would be my opposite side. This would be my adjacent. And then this one would be the hypotenuse. Depending on which angle you're using, whether it be angle A or angle B, is to how they will be aligned. The hypotenuse will not move. It will always be in the same position because it is across from our right angle, which we cannot use. Looking here at example 2, it's saying here, give each trigonometric ratio as a fraction. So we're just going to stack these things together. So remember sine. Sine is our SOH. So for this one right here, to angle A, here's my angle A. Sine is opposite in hypotenuse, so I'm going to have 5 on top, 13 on bottom. And we leave them just like this, as a ratio, a fraction. Cosine. Cosine to this one would be my adjacent side, my adjacent leg, which is 12, over my hypotenuse. And then the tangent is my toa, which is the opposite, 5, over my adjacent, which is 12. We do the same thing over here with my reference angle of C here this time. So sine, remember, is opposite over hypotenuse. This one is adjacent over hypotenuse. And this one is opposite over adjacent. So for my C, the opposite this time is 12. 13 does not change, so 12 over 13. For my cosine, it's going to be 5 over 13. And then for the tangent, it'll be 12 over 5. Notice here that the sine of angle A is the same as the cosine of angle C. Also, the cosine of angle A is the same as the sine of angle C. And then with my tangent, these two are reciprocals of each other. Start paying attention to how our ratios go together, and it's going to make our life easier as we continue to matriculate. Looking at example 3 here, I need to go through and find each of my ratios. So I'm doing angle L. Angle L is right here. So with angle L, this one is, the sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. I am missing a side. In order to find my missing side, I have to go back and remember, oh, this is a right triangle. So how do I find a missing side in a right triangle? I use a squared plus b squared is equal to c squared. This would be my a, my b, and my c, and I plug them into the Pythagorean theorem. So I'm going to have 16 squared plus b squared is equal to 34 squared. 16 times 16 is 256 plus b squared is equal to 34 times 34 is 1,156. I subtract 256 from both sides of the equation. And I see that b squared is equal to 900. I take the square root of both sides of the equation, and I find that b is 30. Now I can go back up here to my triangle and replace the missing side with 30. So this piece right here is 30. I now go and do each of my ratios. My sine of angle L will be opposite, which is 30, over my hypotenuse, which is 34. But remember, anytime we're working with fractions or ratios, we always want to put them in simplest form. So I would reduce this one, and the final answer would be 15 over 17 for it. Now the cosine of angle L, my adjacent would be 16 over the 34 still. To simplify this one, I would have 8 over 17. And then my tangent. The tangent is the opposite over the adjacent, so I would have 30 over 16, which that one would simplify to 15 over 8. Now if we remember, looking back up here at these last ones, oh, the sine A and the cosine C are the same. So the sine L is going to be the same as the cosine of M. So I can use those things, or I can go back and just remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, and stack them together the same way. But remembering how these things relate to each other, this one and this one are the same. Since I've already done the sine L, I can come over here and say 30 over 34, which I know is 15 over 17. And then I know that these two are the same. Cosine L and sine M, those are the same. So I can go through and just put 16 over 34, which is 8 over 17. And then my tangent is the reciprocal, so that would be 16 over 30, which is 8 over 15. trigonometric ratios. As long as we remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sohcahtoa. Enjoy.